Okay, so in this video we're continuing on the 5th year revision C, and what we're going to do in this video is we're not going to do the tables just to save a bit of time, but in the exam you will have to do the tables, okay? So just keep in mind the last video on this. So what we're going to do first and foremost is we're going to graph the functions of these two functions here. So what we need to do is draw out both functions, okay? So it goes from -1 to 3, okay? So the first one's going to be f of x equals 3 to the power of a half x, so 1 over 2. Then press the right button to half the power of x, so it's power button. Then we type in the x, and we know it goes from -1 to 3, so the start is -1 and the end is 3. And we're going to find out all the points on this graph. So it's going to be -1, 0, 0, 3. So -1, 6, 0, 3. Just the blue one here. One after that's going to be 1, 1.5. And then we're going to have 2.75 if I know my stuff. 2.75 because it's getting halved every time. So 2.75. And then 3.375. Okay. The next one we're going to look at is g of x. So g of x here. Going to put this in green. So we're going to have 4 minus 2x. Bracket x. Let me just delete the other stuff here. So 4 minus 2x for this one here. And then once again, we're not doing the formal table like you usually would in the exams. We're just going to write down our points. So -1, 6. -1, 6, 0, 4. 1, 2, 2, 0, and 3 minus 2. Okay, now that we have all the points written out, what we need to do is we need to draw the two of these, okay? So in order to draw the two of these, we just need to pick a suitable scale for both of them. So the blues can go down this side, and the greens can go down the other side, so we can see both points at the same time. Okay. Okay guys, so here we go. So what we have first and foremost is we can see that 6 is the highest value and -2 is the lowest value. So we actually have so many blocks to play with here. So to get it really accurate, what we might as well do is we might as well make every 2 block worth 1. It might make a more accurate answer and easier to deal with the decimals here. Okay. So what we can do here is we can say that the gap of here. So each gap of 2 can be 1. So that's a gap of 1. Just make it a bit longer. And the next one down is -2. Now I'll make sure to use a color I haven't used yet. So that's -1 and -2. So we're going up. So this is going to be 1, 2, 3, 4, 5, and 6. Okay, so we have a nice spread of numbers there. And then we can use a gap of 2 for 1 on this axis as well. So -1, -2, -3, 1, 2, 3, and 4. Okay. So the first point on the curve, which is the blue one, the curve is expected to go like this because it's a power one, and just tail off like so. Okay, so no turning point, just like a tail like that. Okay, so we'll see what we get. So -1, 6 puts up here starting off, then 0, 3 puts it here, then we have 1, 1.5, which is there. Then we're going to have 2.75, so that's 0.5. 0.75 is halfway between 0.5 and 1. And then finally 0.375, this is 0.5 here, so it's going to be a bit underneath that. So we can see the shape of our curve is going downwards, getting halved every time. Okay, so this is quite common. There we go. Now, On the next one, which is the green, which is the line, we have minus 1, 6, shares the first point up here, and then the last point is 3 minus 2, which is this point here. So all we need to do is we just join them both together using the line. And what we get is our two intersection points there. Okay, now the blue line, slight error on the start with the blue line. The blue line should have went more down and around, like so. So there's just a quick mistake on the blue line there. We can fix it now because they're only meant to intersect twice. Okay, so we'll just make sure our blue line is drawn more accurately. Okay, so a bit more like that. Okay, so our questions then asked goes from the graph, estimate the points of intersection of F and G. So find out where they both intersect each other. Well, what's a no-brainer about their intersection? The first intersection point is minus 1, 6 because they both cut at the same point. So minus 1, 6. Now the second intersection point, we see that it happens around here. So this is going to be about 1.2. Call it about 1.25 and 1.25. So 1.25, 1.25. Okay. So what we have here is actually a GeoGebra graph of what we just drew. Okay, so we can see that minus 1, 6 is the point at the start, and as we can see when they go down, you can see that the blue line curves underneath the line, the straight line, and they hit around, let's call it this point here. If we can. Okay, so we can see this point here. This point A is around let's say 1.2 on the Y and about 1.3 or 1.4 on the x-axis. Okay, so we can see that our own line was actually reasonably close, but obviously won't be as accurate as a computer generated graph. Okay, next one. Complete the following table. Once again, we're not going to go through the our own formal table. Now we can see that 0.5s are present, but also we need to do is get from minus 2 to 3. Okay, so what we're going to do is just going to put this in the graph again. So 2 bracket x cubed minus 3x squared minus 12x plus 4. Start is minus 2 and the end is 3. Step is 1. So we're just going to fill in these numbers here. Okay, so minus 2 is 0, 0, 11 and 4, and finally 1 and 2 are going to be minus 9 and minus 16. Okay, draw the graph in the domain minus 2 to minus 3.5. So the top value is 11 to minus 16, so I need about 27 blocks to draw this accurately. Okay, so just going to make these a bit smaller than they would be previously. I'm going to need 27 of these blocks. Okay, and we should also take down all the points here. So minus 2.5, minus 16, minus 2, 0, minus 1, 11, 0, 4, minus 1, 9, 1, 9, 2 minus 16, 2 minus 16, and 3 minus 5. Forget the minus 5 here. Okay, so we're just going to try to draw this out. So when we draw this out, we want the 11 to be the top of the graph, so we might just do it up to 12. You never know, you might have to go underneath the you might have to go underneath over the graph. Okay, so we're going to start with minus 12 on top, or sorry, plus 12 on top, and we're going to go down in each block is worth 1, so that's this gap of 2 blocks is going down in 2s. Okay, so 6, 4, 2. Then we can put in our x-axis, and then we go back down for the y all the way down to minus 16. So minus 2, minus 4, minus 6, minus 8, minus 10. So we just got to extend this a bit further than we would have liked. Minus 12, minus 14, minus 16. Okay, so we have this big line here. Okay, so we're going to start drawing in the x-axis. Okay, so what we're going to do is we have to go all the way back to minus 2.5. So gaps of 2 would be perfect here, because that would be minus 2.5 there. And then we're going to go gaps of 1 on the x-axis, 3, 4. So we're going to draw the line now. So we're going to have minus 2.5 minus 16. So minus 2.5 minus 16 is going to be all the way down here. And then we're going to have minus 2 minus 16 minus 2 0 going to be up here. We're going to have minus 1 11, which would be all the way up here. Then we're going to have 0 4 down here. We're going to have minus 1 minus 9, which is here. I say minus 1 9, which is here. And then we're going to have 2 minus 16, just going to drop dramatically down to here. And then we're going to have 3 minus 5, which is going to be here. Now just double check your workings. So it actually was 1 minus 9. Okay, so it wasn't 1 plus 9, it was 1 minus 9. So we just need to adjust that one because it was a bit off that point. Okay, so it was 1 minus 9. And 1 minus 9 is located here. Okay, so what we gotta do is we gotta start attaching them together. So first part here. Okay, let's give it one more go here. Okay, we'll get a more accurate drawing at this in a minute or two. So we go all the way up through the first point and keep going up, reach the second point, and do a quick, very sharp turn here, all the way down. All the way down to minus 16, and then all the way back up. Now we can see that this is a very sharp graph. Okay, so we can see it's a very sharp graph. So here we can actually see a GeoGebra representation of the graph we just drew, and you can actually see how abrupt the turning points are, the local maximum, the maximum turning point, and the minimum turning point. You can see that they're actually very abrupt. Okay, so if we're actually just to zoom in on this graph, you can actually just see how sharp the turns are in the graph, and just the pattern of the way to draw this. You need a very fine hand for this graph. Okay, now that that's done, and this is our graph here, obviously hard to get it as accurate as the one we just saw. Write down the coordinates of the local max and local min. Okay, so the local max is going to be the maximum turning point. We just circled it there. It's going to be minus 1 11, and the local min, which is the max, and the local min is going to be this one here, which is going to be 2 minus 16. Now remember, the minimum has the smaller y value, and the max has the bigger y value. Use a graph to find the values for x for which fx is decreasing. Now what decreasing means is that it means it's on its way down. So decreasing means it's on its way down on the graph, okay? So what we can do here is we can just have a quick look up and we can see when is the graph on its way down. Okay, so decreasing would also mean f of x means the graph is on its way down, okay? So let's have a look. Now, at the moment it's increasing, so from the very beginning it's increasing, so it's on its way up, then it gets flat. So it starts at remember the values of x we're looking for. It starts at x equals minus 1, just after x equals minus 1. Now it's decreasing, you're still decreasing, and then it stops decreasing at x equals 2. So in between minus 1, x values of minus 1 and minus 2 is and plus 2 is what we're looking for. So it's going to be minus 1 is smaller than x, and x has to be smaller than 2. That's when it's decreasing. Okay? So we'll just get rid of what we just did there a second ago. Clean up this graph. Okay, next question. Estimate the values of x for which f of x equals 0. F of x equals 0 means the y value is 0. So what we have here is x equals minus 2 is the first one. X equals, I think that's less than 0.5, about x equals 0.2 is the second one. Okay, and there will be a third value, but it has to keep going, so we need to find out the next point in line to do that. So we stopped at 3, but we could redo this graph and we could draw in the we could have a new end of 4, and we could find out where 4 is. 4 is at 36. Okay, so that's more or less well out of this graph. Okay, so what could happen is we could revert back to our GeoGebra, which has the full graph, and we could realize that it crosses at about 0.2 and the next one crosses at about 3.2. Okay, but you can only work with the graph you're given, so you aren't asked to draw the last point, so you won't be able to get this answer here, so you'll only be able to get the first two. Okay. Next one, graph the function of f of x equals x cubed minus 6x squared plus 9x plus 6 in the domain 0 to 4. Use the trapezoidal rule to estimate the area between the curve and the x-axis. Okay, so to do this, what we're going to do is we're going to go back to the calculator once again. So this time we have x cubed minus 6x squared plus 9x. So we'll replace this with 9x. And we don't have 4, we have 6. So once again, you could formally do your table, and that's what you expected to do in your exam, but right now we're just going to concentrate on our own answers. Okay, so we're going to write down all the points. So 0, 6, 110. 0, 6, 1, 110. 2, 8. And we're going to have a 2, 8, 3, 6. And 4, 10. Okay, so we're going to graph this function first and foremost before we answer the second part of the question. So we have to go from 0 to 10. It's a very easy graph to do. So this would be one of the easier graphs we've drawn in class. So we're going to have this as a 1, 2, 3, and 4. And then up on the x-axis we'll have a we'll just go up in ones as well as 2, 4, 6, 8, and 10. So what we're going to have here is the following. We're going to have 0, 6 being the first point. 110 being the second point, 28 being the third point, 36 being the fourth point, and 410 being the last point. So we're just going to quickly draw this in here. Okay, now what we have to do is we have to use the trapezoidal rule to estimate the area of this object. Okay, so what we can see is by the trapezoidal rule is that we have to get all the heights. Okay, so these heights here is what we're looking for of each one in between that and the x-axis. So you'll see in the question it says estimate this, the trapezoidal rule to estimate the area between the curve and the x-axis. So the area that we're actually trying to estimate is this area here. Okay, so if it's color in green, this is all the area that we're looking to estimate. Okay, so we're trying to estimate that. Now, what we got to do to use the trapezoidal rule is we got to find out what this h is. And what h means is actually not, it's conversely, it's not the height, it's actually the width. And the width in between each of our readings, see we know the height for each point, so the width in between each of our readings is 1. So a is going to equal 1 over 2. Now, this part here, y1 means the height of the first line. So y1 is actually 6. Yn means the height of the last line, and the height of the last line is 10. Okay, now in this case it goes directly up. If it doesn't go directly up, as in imagine it tracked this red line here, that means that the height of the first one would be 0. But that's not in this question. Okay, now we got to do 2 times the other heights. So 2 times the other heights will be, the other heights are going to be this one here. So that'll also have y2 in it, y3, y4. So the second height is 10. So 2 times 10 plus 2 times 8 plus 3 times 6, 2 times 6, sorry, and close the bracket. Next thing you're going to do is just going to go to your calculator and use your calculator to answer this question. So we're going to get a half, 1 over 2. Open up the large brackets, we're going to have 6 plus 10 plus 2 times 10 plus 8 plus 6, close the bracket, close the second bracket, and what we get is 65 over 2. 65 over 2 is going to be 32.5 units squared, because they're going to be square units. If it was measured in meters, it'd be meters squared, but we don't know what the units are in this question. Okay. Next part, the differentiation. Now, what you got to remember with differentiation is, if the first equation given to you is a distance equation, that means that the first derivative will equal velocity or speed, and the second derivative equals acceleration. Okay, so it goes find the speed of the car after 2 seconds. Speed meaning the first derivative. Differentiate. Put 4t plus 2 in. So differentiate, you get 4t plus 2. This means the speed of the car is given by 4 multiplied by the time plus 2. We know the time is 2 seconds. So it's going to be 4 multiplied by 2 plus 2. This will be 8 plus 2, which is 10. Look at your units. Meters. T is in seconds. Meters per second. Okay, find the acceleration of the car. The acceleration of the car is the second derivative. This means differentiate the first derivative, and what you get is 4. The acceleration of the car is 4 meters per second squared. The distance from point A to B is 24 meters. After how many seconds does the car reach point B? Distance formula, S equals 24. This means that this formula here, 2t squared plus 2t, so 2t squared plus 2t equals 24. Bring 24 over to your side, you get 2t squared plus 2t minus 24 equals 0. You could do the minus b formula where a equals 2, b equals 2, and c equals minus 24. But in this one, I'm just going to divide by 2 because each number here is divisible by 2. And what I'm going to do is go and get the reference number. It's an easy reference number question. So reference number is going to be 1 by minus 12, which is minus 12. Break up minus 12 into two factors that add together to give you plus 1. This is going to be minus 3 plus 4. So our answer will be t minus 3, t plus 4 equals 0. Then we're going to get t minus 3 equals 0. Bring over the 3. So t equals 3. Or bring over t plus 4 equals 0, bring over the 4, t equals minus 4 seconds. Remember, time can't be negative, therefore the answer is 3 seconds. Okay, just pause it there. In the next question, the diagram shows the cubic function, so it shows the two turning points. You have your maximum and your minimum. Find the coordinates of the point at which f cuts the y-axis. So where does it cut the y-axis? Okay. Now what you have to remember about this graph is that f of x here is the y value. Okay. Right. So where does it cut the y-axis? On the y-axis, x always equals 0. So what we can do is we can replace x with 0. So we're going to get 0 cubed minus 0 squared minus 0 plus 6. This means it hits at the point 0, 6, where x equals 0, and because x equals 0, y must be 6. F has a minimum turning point at 1, 5. Find the coordinates of the maximum turning point. I'll find you how to get the coordinates of both of them. Okay, so to get a turning point, what you do is you get the first derivative and you let it equal 0. So the first derivative is, we're going to differentiate it, and what we get is x cubed turns into, bring the 3 in front, so 3, take 1 away from the power, 3x squared. Bring the 2 in front, take 1 away from the power, becomes 2x. Remember, this is minus 1x. When you differentiate an x, you just when you differentiate a number with only an x, you get rid of the x. When you differentiate a normal number, it disappears. So we're left with 3x squared minus 2x minus 1 equals 0. So what we can do next with this is we can find out we can solve this using the reference number. Okay, the reference number is 3 multiplied by minus 1, which is minus 3. The two of these have to differ by minus 2. So this can be minus 3 and plus 1. Now remember, you could also use the minus b formula. This is a more difficult reference question because it's not x squared this time. So you have to write down an extra step where you replace 2x, minus 2x with minus 3x plus 1x. Minus 1 equals 0. Factorize the first two, so what you get is 3x into x minus 1. Remember, both brackets have to be the same. What number comes outside here to multiply? What multiplies x to turn into 1x is the answer to number 1. So 1 multiplies by x to give you 1x, and 1 multiplies by minus 1 to give you minus 1. Likewise, 3x multiplies by x to give you 3x squared. 3x multiplies by minus 1 to give you minus 3x. Let's factorize this again. So you're going to get 3x and the plus 1 in one bracket, and the x minus 1 in the other bracket. So what we get here is x equals 1, bring over the 1, x equals 1, or 3x plus 1 equals 0, bring over the 1, 3x equals minus 1, and then x equals minus 1 over 3. Okay, now we already know that 1, 5 is the minimum turning points, so we can just find out these two turning points anyway, because we know f of x equals x cubed minus x squared minus 1x minus 6. So what we can do is we can find out what is the y value when x equals 1 by replacing x with 1. So we get 1 cubed minus 1 squared minus 1 times 1 minus 6. Put all of this into the calculator, we'll get 1 minus 1 minus 1. So let's have a quick look at this again. So we get x cubed minus x squared, and that is plus 6 at the end. Okay, so that makes sense now. Plus 6. So what happens is when we add all these together, we're going to get 5. So the minimum point is 1, 5. But we won't know it's a minimum just yet. Okay, and the next one we got to get is f of a third, because we know the other x value is minus a third. So f of minus a third, or the y value when x equals minus a third, is minus a third cubed minus a third squared minus 1 times a third plus 6, not minus 6, plus 6. We're going to use the calculator for this one. Minus a third cubed minus bracket minus 1 over 3 squared minus 1 times minus a third plus 6. And what this turns out to be is 6.185. Okay, so it goes find the coordinates of the maximum turning point. So we can see that it's around minus a third is around here, and it's obviously around 6.1 because it's just above the 6 mark is what we're expecting. Okay, so this point here is minus a third, 6.185. Okay guys, that concludes the end of this video. Best of luck in the summer test.